Part B asks us, based on the values in the table, what's the smallest number of instances at which the acceleration of the plane could be 0 on the interval from 0 to 40? Justify your answer. So we're trying to figure out when the acceleration could be 0, the minimum number of times. Well, what's the relationship between acceleration and velocity? Derivative of velocity is acceleration, right? So the slope between points would have to be what? 0, right? The slope is 0. That means our acceleration is 0. Well, let's look at these points. What's happening from 7 to 9.2? It's increasing, right? 9.2 to 9.5, increasing. Then from 9.5 to 7, it decreases, right? So somewhere in here, it has to change from increasing to decreasing. So if it changes from increasing to decreasing, what's going to happen to the acceleration? It's got to be 0 somewhere in there, right? So it has to happen there. Right, so now from 7 to 4.5, decreasing. 4.5 to 2.4, decreasing. 2.4 to 2.4, it's the same, it's 0. So it could happen one more time here. And then 2.4 to 4.3, that's increasing, increasing. So like somewhere in here, that's also going to have to be a derivative of 0. So there's 2 times where it's changing from increasing to decreasing or decreasing to increasing. It has to happen at least twice. It could happen more, like in between 30 and 35. It might go up to like 6 and then back down to 4.3. We don't know. But we know at least twice it's going to have to change. So for part B, the velocity changes from increasing to decreasing sometime between where t is between 0 and 15, and it changes from decreasing to increasing sometime between t 25 and 30. The acceleration of the plane must be 0 at least twice.